Hello, how to solve for s in this equation? 8 to the power of s minus 2 to the power of x divided by 6 to the power of x minus 3 to the power of x is equal to 2. Solution. Then 8 to the power of s can be written as 2 to the power of 3 to the power of x minus 2 to the power of x divided by this 6 to the power of s can be written as 2 multiplied by 3 to the power of x minus 3 to the power of x is equal to 2. Then take note of this, that if you have a to the power of m to the power of n is equal to a to the power of n to the power of m, this is equal to a to the power of mn. This can be written as 2 to the power of 3x minus 2 to the power of x divided by 2 to the power of x multiplied by 3 to the power of s minus 3 to the power of s is equal to 2. That is, here, if you have a b to the power of n, this is equal to a to the power of n multiplied by b to the power of n. Then this can be written as 2 to the power of 3s is 2 to the power of s bracket. Here we have 2 to the power of 2x minus 1, then divided by, here we have 2 to the power of s multiplied by 3 to the power of s minus 3 to the power of s is equal to 2. Then we have 2 to the power of s bracket 2 to the power of 2s minus 1 divided by, here 3 to the power of s is common, let's bring it out. We have 3 to the power of s bracket this divided by this, we have 2 to the power of s minus this divided by this 1 is equal to 2. Then this can be written as 2 to the power of s bracket 2 to the power of s square minus this one can be written as 1 square divided by, we have 3 to the power of s bracket 2 to the power of s minus 1 is equal to 2. Take note of this, that if you have from the numerator here a square minus b square, this is equal to a plus b bracket a minus b. Because this is in the form of perfect square, then we have 2 to the power of s bracket 2 to the power of s plus 1 bracket 2 to the power of x minus 1 divided by 3 to the power of x bracket 2 to the power of x minus 1. And this will cancel this. That is, here we know that 2 to the power of x minus 1 is not equal to 0. So here 2 to the power of s is not equal to 1. Therefore x is not equal to 0. So here we have 2 to the power of s bracket 2 to the power of x plus 1 divided by 3 to the power of x is equal to 2, and this is equal to 2. Now from here, let's multiply both sides of this equation by 3 to the power of x. We have 3 to the power of x multiplied by 2 to the power of s bracket 2 to the power of x plus 1 divided by 3 to the power of x is equal to 2 to the power of 2 multiplied by 3 to the power of x. Then this, we cancel this. Now we have 2 to the power of x bracket 2 to the power of x plus 1 is equal to 2 multiplied by 3 to the power of x. Now let's divide both sides of this equation by 2. This divided by 2, this divided by 2. This we cancel this. We have 2 to the power of x bracket 2 to the power of x plus 1 is equal to 3 to the power of x, then divided by 2. But this 2 is the same thing as 2 to the power of 1. So this can be written as 2 to the power of x minus 1 bracket 2 to the power of x plus 1 is equal to 3 to the power of x. Now at this point, we want to test if x is greater than or equal to 2. So we can test from here if x is greater than equal to 2. Then we have 2 to the power of x minus 1 bracket 2 to the power of x plus 1 is equal to 3 to the power of x. And if x is equal to 2, here we have 2 to the power of 2 minus 1. That is 2 to the power of 1, which is 2. Here is even. And then here, if x is equal to 2, we have 2 to the power of 2. That is 4 plus 1, 5. Here is odd. This is odd. And here, if x is 2, we have 3 to the power of 2. That is 9. This is odd. Now let's see. If you multiply even and odd, let's see what will give us. If you multiply this with this, here is 2 multiplied by 5, that is 10. It's going to be even. And this is odd. So since it's even, it's not equal to this odd. Therefore, we conclude that no solution. If s is greater than or equal to 2. Now let's see if s is equal to 1. Now if s is equal to 1, we have 2 to the power of x minus 1 bracket 2 to the power of x plus 1 is equal to 3 to the power of x. Now let's see if s is 1. This is 2 to the power of 1 minus 1. That is 0. We have 2 to the power of 0 bracket. Here is 2 to the power of 1. That is 2 plus 1. 3. Then it's equal to 3 to the power of 1 is 3. Now let's see 2 to the power of 0. That is any 2 to the power of 0 is 1. We have 1 multiplied by 3 is equal to 3. Then 1 multiplied by 3, this is 3, is equal to 3. meaning that s is equal to 1 is a solution. Then from here, we conclude that s equal to 1 is a solution. So this shows that since 3 is equal to 3, s is equal to 1 is a solution. Now, let's consider if s is a negative number. Let's see what will happen. Let's check if s is equal to negative number. That is where n is greater than or equal to 1. Then we have 2 to the power of x minus 1 multiplied by bracket 2 to the power of x plus 1 is equal to 3 to the power of x. Now, if x is equal to minus n, we have 2 to the power of negative n minus 1 multiplied by this 2 to the power of negative n plus 1 is equal to 3 to the power of negative n. Then this can be written as 2 to the power of, here we have minus 1 bracket n plus 1 multiplied by 2 to the power of minus n plus 1 is equal to 3 to the power of minus n. Then this is 2 to the power of minus 1 bracket n plus 1 multiplied by, let's take the reciprocal of this. This is 1 divided by 2 to the power of n plus 1 is equal to, this is 1 divided by 3 to the power of n. Now, this can be written as, if you take the reciprocal, we have 1 divided by 2 to the power of n plus 1 multiplied by 1 divided by 2 to the power of n plus 1 is equal to 1 divided by 3 to the power of n. Now from here we have 1 divided by 2 to the power of n plus 1 multiplied by, here if you take the LCM we have 2 to the power of n and the numerator become 2 to the power of n plus 1 is equal to 1 divided by 3 to the power of n. Now from here, so now from here we have, here 1 multiplied by 2 to the power of n plus 1. This is 2 to the power of n plus 1 divided by, here we have 2 to the power of n plus 1. This is 2 to the power of n. This can be written as 2 to the power of 2n plus 1 is equal to 1 divided by 3 to the power of n. Let's cross multiply. If you cross multiply, we have 3 to the power of n multiplied by 2 to the power of n plus 1 is equal to, if you multiply this by 1, we have 2 to the power of 2n plus 1. Now, let's see from here. Let's check now. If n is equal to 1, we have 3 to the power of n, which is 3 to the power of 1. This is odd. Then here, if n is 1, 2 to the power of 1 plus 1, that is also 3. We have odd. Then, and here is 2 to the power of 2n. That is 2002. Then, plus 1. 2n, that is 2002 plus 1. That is 3. 2 to the power of 3. That is even. Now, let's see. If you multiply this odd by odd, what will you get? Here we give you odds. And at this point, this is not equal to this even. Then we conclude that s equal to minus n has no solution. Therefore, the only solution we have is s equal to 1. This is the only solution. I hope you enjoyed this video. Thank you for watching. Please don't forget to like, share, comment, and subscribe to my channel. Bye.